This is problem C about the Earth's orbit, and the problem reads: the Earth orbits the Sun once a year, 3.16 times 10 to the 7 seconds, in a nearly circular orbit of radius 150 billion meters. With respect to the Sun, determine A, the angular speed of the Earth, B, the tangential speed of the Earth, and C, the magnitude and direction of the Earth's centripetal acceleration. Let's see what we're supposed to figure out first is the angular speed of the Earth. So we're going to have omega equals something, and what they give us is the time it needs for one orbit. So I'm going to put time down here, and so I put a check mark there, and they said first the angular speed, so I'm going to put a question mark here. But that also means that we need, in order to figure this one out, that we need the angle, delta t divided by delta theta divided by delta t equals, and well, they say one orbit, and therefore we know what theta is. It's 2 pi, and then we just need to plug in the numbers, and we come up with the angular speed in radians per second, 2 pi divided by the 31,600,000 seconds. By the way, if you want to check that number, multiply 60 seconds times 60 minutes times 24 hours times 365 days, or 365 and a quarter days, in order to come up with those 31.6 million seconds. Okay, so that's part A. Part B, they want us to figure out what is the tangential speed of the Earth. So Vt equals, and for that one we're going to use equation r times omega. So we have r times omega, and they give us what r is. It's the 150 billion meters. That is 93 million miles. And from up here we have figured out what omega is, so we just plug that in and we come up with the tangential speed in meters per second. And in part C, they want us to figure out the magnitude and direction of the Earth's centripetal acceleration. So we're supposed to figure out AC, and that is r times omega squared. And again, r is given, and omega we're calculating in the first part. So we plug those in, and we come up with the acceleration in meters per second squared. And they want to know what the direction is. Well, the centripetal acceleration is defined at that it points towards the center of the circle. In that case, of course, towards the center of the orbit, which is towards the Sun. That, of course, is the centripetal acceleration pointing in this direction. That's also the centripetal force provided by the Sun's gravity. Of course, the reason that the Earth doesn't fall in there because it also has a tangential velocity which tries to pull it out, not pull it out here, but due to which it moves here due to its inertia, its tangential velocity. But of course gravity is pulling the Earth over there, and the two combined then make an orbit. By the way, the answers here, this one is going to come out to a really small number because you're dividing here 2 pi by 31.6 million. This one here is actually coming out to a relatively large number. In the American system, it's roughly 20 miles per second. Okay, 20 miles per second. The Earth is going at 70,000 miles an hour in its orbit. This one here again comes out to a relatively small number. Oops, I didn't mean to do that.